In this problem, we're looking at a reaction between lead nitrate, which is our first aqueous reactant, with sodium bromide, our second aqueous reactant. When we mix these two together, we get lead bromide, which is a precipitate, and the remaining product is sodium nitrate, which remains in solution. Now, the one thing we know going all the way back to Dalton is that chemical reactions are just simply rearrangements of atoms in whole number ratios. And since the mole is just a counting unit for atoms, we know that reactions occur in whole number ratios of moles as well. Now, it's understood we have a coefficient 1 out in front of the lead nitrate. So 1 mole of lead nitrate reacts with 2 moles of sodium bromide. We can write that as a simple proportion. So we'll do that here. Now, the thing about it is we don't know how many moles of lead nitrate we have. What we do know is the mass. So what we're going to do is to rewrite this proportion of mole ratios in terms of unknowns. So we know that if we have X moles of lead nitrate, because there's a 1 to 2 ratio between moles of lead nitrate and moles of sodium bromide, we must therefore have 2x moles of sodium bromide. So what we need to do then is to figure out how many moles X is, and the way we'll do that is by a simple mass to mole conversion. 28.8 grams is going to be our X moles of lead nitrate. Now, to get that mass mole conversion to happen, we're going to use the molar mass of lead nitrate, so we'll develop that over here. In each formula unit of lead nitrate, there's 1 atom of lead, so we'll multiply 1 times the 207.2 grams per mole in the periodic table for lead. For nitrogen, there's 1 atom of nitrogen, but times 2, since we have 2 nitrate units. So we'll multiply 2 then times the molar mass of nitrogen from the periodic table. And for oxygen, there's 3 atoms of oxygen in each nitrate unit, 2 nitrate units. 3 times 2 then is 6 atoms of oxygen in each formula unit of lead nitrate. So we'll multiply 6 times the molar mass of oxygen from the periodic table. What we find then is that 1 mole of lead nitrate has a mass of 331.208 grams. So we can write that as a simple ratio, which we'll do here. Now, we don't have 331.208 grams of lead nitrate. We have 28.8 grams. So we know that that ratio of 331.208 to 1 mole must still hold. So we'll assign 28.8 grams of lead nitrate then to be proportional to X moles of lead nitrate. And then we'll solve for X. The way we can do that is just a simple cross multiplication. So on the left side, we'll have X times our 331.208. And on the right side, we'll have the 1 times the 28.8. Now, the way we would solve that for X, very simply, we're going to divide both sides by 331.208. When we do that, we'll obtain X, and X equals 0.08695 moles. So that X we can simply plug into here in our mole ratio equation. Actually, it's even simpler than that, since we know that if we have X moles of lead nitrate, we must have 2X moles of sodium bromide. So we can very simply take the X moles of lead nitrate and multiply by 2. When we do that, we find that we need 0.1739 moles of sodium bromide to react with that 0.08695 moles of lead nitrate. So at this point then, we need to convert our moles of sodium bromide into mass. That moles to mass conversion, again, is going to rely on our molar mass. So let's develop the molar mass of sodium bromide. There's 1 atom of sodium in each formula unit of sodium bromide. So we're going to multiply 1 times the 22.990 grams per mole of sodium atom from the periodic table. 1 atom of bromine in each formula unit of lead bromide, so 1 times the molar mass of bromine from the periodic table. When we add that together, we get 102.894 grams in each mole of sodium bromide. We can write that again as a ratio. Now, we don't have 1 mole of sodium bromide. We have 0.1739, but we know that the simple ratio between mass and moles for bromine must hold. So what we can do then is to write that ratio like this, where instead of 1 mole, we'll have 0.1739, and then that gives us an unknown amount of grams of sodium bromide, but the ratio must be the same. The proportionality has to be maintained. So then again, it's a simple matter of solving by cross multiplication. So on the left side, we're going to have our unknown y times the 1 mole of sodium bromide. And that will equal on the right side the 102.894 grams times the 0.1739. So there's the right side of the equation here. Now, pretty easy then to solve for y. We just need to divide both sides by 1, which is pretty easy. When we do that, the answer we get for y is 17.9 grams of sodium bromide. So that's the mass of sodium bromide we need to react completely with our 28.8 grams of lead nitrate. Now notice that our answer, 17.9 grams, is 3 sig figs, just like it was for our mass of lead nitrate. So if you're having trouble solving stoichiometric problems by the method we developed in class, hopefully this proportionality method will help you.